Okay, so let's take a look at Monday's assignment, which was chapter 7.1 on angles of polygons. This topic is talking about generally like the interior angles of polygons. So the particular polygon that we've worked with so far in a lot of detail is the triangle. And at this point, we should be feeling comfortable with the idea that on the inside of a triangle, we always have 180 degrees. Okay, so these three angles, when we put them together, we get 180 degrees on the inside. Those are the interior angle measurements of a triangle. Now we're going to kind of go ahead and try to figure out what can we expect for other shapes. And it turns out we don't really have to spend too much time on these other shapes because they all have the ability to be broken into triangles. So for example, if you have a square or a rectangle, if you have a five-sided polygon like a pentagon or a hexagon, any of these things can be broken into triangles. Now, I've seen that in different ways. One of the ways I've seen it is like this. You kind of go from each vertex to the center. Okay, and that is one option for how you could break something up into triangles. The one that I saw in the book, though, that we kind of discussed earlier this week, was that you can take one corner and you can just go out to all the other corners. So like this. And that is another way. I kind of like this way. Maybe a little better than going into the middle, because then when you go to the middle, there's an extra step where you have to kind of, so let's say I took this rectangle and I went to the center. So I would have four triangles with 180 degrees each, right? Each of these four shapes would have 180 degrees in them. However, if I'm asking for the interior angle measurements of the rectangle, I'm only asking for these four corners. I'm not interested in that circle of angles in the center. So after I add 180 times 4, after I add these four triangles together, I would have to subtract out this 360. So if you don't go to the center, if you just go from one corner out to the other corners, then you don't end up with that problem. So for example, if we're looking at this hexagon, well, if we want to know what the interior angle measurements are of a hexagon, then it's just going to be all the angles of these four triangles, right? Each part of this, there's no angles that are not on the inside edge. So all of these are the ones that we want. So we end up with a hexagon saying that we've got four triangles that are 180 degrees apiece. With a pentagon, we've got three triangles that are 180 degrees apiece. With a square or a rectangle, we're going to end up with two triangles. So if you kind of compare the amount of triangles we can make to the number of sides that we start with, it's always two less. So if you take the number of sides and you take away 2, you get the number of triangles you can make. Okay, so like starting with let's start with this one. So if you have 3 sides, you take away 2, well, you make one triangle here. Okay, it is one triangle. If you have a square, you got 4 sides, you take away 2, you can make 2 triangles. You have a 5-sided shape, you can make 3. You have a 6-sided shape, you can make 4, and that just goes on as as big as you want it. So if you had some like 100-sided shape where they were all very, very, very small little sides, if there are 100 sides, then you'd expect to be able to make 98 triangles in there. Okay, so it's just always how many sides you have minus 2. And then once you have that, then you know what all those interior angle measurements are. So we're going to use that strategy to work through this set of problems. Okay, so on the first one here, we've got this 4-sided shape. So we've got a quadrilateral. That's what we'd call it. And in order to find that missing x down here, we need to know what we expect to have in the first place. So if I have a four-sided shape, when I cut that into two triangles, I get two sets of 180 degrees, right? I get 180 degrees and I get another 180 degrees because each of those triangles has 180 on the inside. Well, that would give me, what, 360 altogether. And then from there, I would quite simply just say, okay, all four of these corners together need to add up to 360. So I'm going to take that 360, I'm going to get rid of the 107, I'm going to get rid of the 47, I'm going to get rid of the 138, and that should tell me what's left over, that bottom left corner. So let's put some of these together. So I'm going to put all these numbers together first. That would be what? 154, 280, 290, I think 292. And then those two numbers, so I'd have to add 8 to get to 300, and then I'd add another 60, so their difference must be 68. Let's try that out. Okay. Now for this one, any four-sided shape is going to have 360 degrees. So it doesn't matter if it's, a square where it's 90 and 90 and 90 and 90, where it's real obvious to see that. No matter how we kind of shift things around, if we slant it on its side, some angles get smaller, some angles get bigger, and in the end, it all adds up to the same amount, 360 for a quadrilateral, or a four-sided shape. Okay, it says find the sum of the interior angle measures of a convex 16-gon. Okay, so I think after a certain point, they stopped like naming these things. There's triangles, quadrilaterals, pentagons, hexagons, heptagons, nonagons, octagons, decagons. Eventually, they stopped naming them and they just start using the number of sides. So they're calling this one a 16-gon. So I could go through and I could like draw out 16 sides and kind of think about it as a picture. I don't really want to do that because that's a lot of sides and it'll make for a messy picture. That's 8 right now. So if I connected these all, that would be 16, I think. The key idea would be that we just remember when we cut this into triangles, when I take one corner and I start going out to the other vertexes, there are only two places that I don't have to go out to because those are the two places I am already connected to. Right, from this one, the next one over I'm already connected to, the next one over that direction I'm already connected to. So there's like a total of 18 positions around the side of this shape. Or sorry, not 18, 16. But I don't have to go to 2 of them, so I'm only going to go out to 14. I'm going to make 14 triangles. So we don't really need to draw it out and see that every time. We just want to remember that however many sides there are, so if this is my number of sides, there are 2 less triangles that I can make. I'll just call that T. That'll be the number of triangles. So in this case, we would expect to have 14 triangles. And each one of those 14 triangles should have 180 degrees. Okay, so the total sum of all of those angles is just going to be whatever 14 times 180 is. So let's try that real quick. So that should be, let's go to a calculator so I'm not wasting too much time. So we ended up with a total of probably a pretty large number, 2,520. Okay, so this one is kind of going in the opposite order. So they're going to tell us what the sum is, and then they're going to ask us how many sides it has. Well, if our general idea is we took our number of triangles, say t, my number of triangles, and I multiplied it by 180 to get the total sum, then this is basically like what that last step would have looked like if I was going in the direction we did on the last problem. So we would have had some amount of triangles, so some number there, times 180 degrees would equal 1440. Well, if we're trying to solve for t, if we want to know how many triangles there are, then we need to divide both sides by 180. Right? Whatever we are doing to it right now, we need to do the opposite. So if we're multiplying by 180, then we need to divide by 180. Right. So that step should be clear to you guys. So if totally different example, if I have 3t equals let's say 18, I don't want to know what 3t's are worth. I only want to know what one of them is worth. So I just divide both sides by 3. That tells me that 1t is worth a third of this. 3t's was worth this whole thing. So one of those t should be worth a third of it. 6. So that's what we'd be doing. Let's go over to the calculator again. 1440 divided by 180. Number of triangles in my shape that I would be able to make by our strategy of connecting those corners would be 8. Now, that does not mean I have an 8-sided shape, right? So our number of sides minus 2 was going to be the number of triangles we got. So if the number of triangles we have in this one is 8, that means our number of sides must be 10. Right? I would add 2 to both sides of that equation, and I would get that I have a 10-sided shape, or a decagon. Nothing terribly different on this one. So this is a 6-sided shape. So we're going to say n, I'm going to start with this equation, n minus 2 equals t. My number of sides minus 2 equals the number of triangles. Well, I've got 6 sides, which means that I should have 4 triangles that I could make if I divided this shape up. I'm going to take my number of triangles times 180 degrees to get my sum of the angles. Okay, so in this case, I have 4 times 180. Which would be, what would that be? 4 times 200 would be 800, and we're going to take away 420. So 720 degrees, I think is what I'm looking for. Okay, so 720 is what I should get if I add up all the sides, which means that if I take 720 and take away these 5 sides, that should leave me with my answer. Okay, so let me see if I can add these all together real quick. So 103 and 118 would be 221. Then we'd have 321, 371, 375, 465, 469, 470, 490, 590. I think I have a total of 590 with all this stuff. Okay, difference between those two numbers would be 30 and 100. So we get 130 degrees. That looks pretty good based off the picture. This angle looks a little bit bigger than this one. This was 120. So 130 sounds like it could be reasonable. Okay. So this lesson's not too terribly tricky. It's just that you got to understand that first idea of dividing your shape into triangles, and that you always get two less triangles than the number of sides that you started with. Okay, so we have a regular 18-sided shape. So if we have 18 sides, then we should be able to make 16 triangles. If we make 16 triangles, then we should be able to multiply that number by 180 to get the sum of the angles. So we have 16 times 180 equaling 2880. Now, I don't think they asked me for the sum. Maybe they did, but yeah, measure of each interior angle. So if you have, let's kind of build our way up. If we had 3 sides, then we have 3 interior angles. If we have 4 sides, we have 4 interior angles. So if we have 18 sides, we're expecting to have 18 interior angles. Well, that 2880 number was the sum of all 18. They don't want all 18, they just want one of them. So take that 2880 and divide by 18, we'll figure out what one of those was worth. I'm going to take this, divide it by 18, and we end up with 160. Okay. Now for the next part, it says, what is the measure of each exterior angle? So I'm going to go back to an image that I showed you guys on Monday. Exterior angles. So with exterior angles, there's not so much that you need to do with like calculating anything. Really, it's just that you're going to take 360 degrees and you're going to divide it by the number of sides. Now, the reason you're going to do that is going to be kind of evident when we look at this image here. Get it open without it bouncing around too much. So if you were to take any regular polygon and you were to extend the lines out and measure these exterior angles. So exterior angles is just when you continue the line out. Let me get my pad back up here. When you have a shape and you continue a line out, the angle formed outside is called the exterior angle. So if we do that with all 3 sides, then we end up with 1, 2, 3 exterior angles. Now those 3 angles, if we bring them together, is being shown in the image here. So if we kind of shrink the sides down so those angles come closer, eventually they just make a full circle, which makes sense because going from here to here, and then we have to continue there, and then we continue there. Well, we've gone all the way around in a circle. We've circled the outside of this shape. We've started at one place, and we've moved through, 1, 2, 3 steps back to where we started. So we've gone all the way around. So it should make sense that we've gone 360 degrees around the outside of the shape. Now that's going to be true for all of these, for any shape that you have. It's just going to be however many sides you have is how many exterior angles you'll make. So like a pentagon with 5 sides will have 5 exterior angles. But those 5 angles will still add up to 360 because you're still going all the way around the shape. So if in our problem we have 18 sides, well, then we've got 360 degrees that was made out of 18 little exterior angles, 18 parts. 36 divided by 18 is 2, so I think this is just going to be 20. Cool. Okay, last one from Monday's assignment. It says the measure of each interior angle of a regular polygon is 162 degrees. Find how many sides we have. So lay out our thought process that we usually have. We have got some number of sides, which is what we're searching for in the end here. Minus 2 equals the number of triangles. The number of triangles times 180 equals the sum of the angles. And this one says that the measure of each interior angle is 162 degrees. So we don't want the sum. I'm going to leave that sum. I'm just going to write it as, I guess I'll just write it as sum, not sum of angles, so I don't have to write so much next time. Okay, so this gives me some large number. Now, if I divide that number by the number of sides, that'll tell me what each individual angle is worth. So this problem kind of has us lay out all of these steps together and then work our way backwards through them. Sorry, my computer's being a bit slow here. Okay, so our number of sides minus 2 is the number of triangles we can form. Each triangle has 180 degrees, so that tells us the entire sum of the angles. If we take that sum and we divide it by the number of sides, okay, that number from the beginning, well, as I said just a moment ago, if you have 3 sides, you have 3 angles. If you have 4 sides, you have 4 angles. If you have 5 sides, you have 5 angles. So we should be able to divide this total number, this total angle value, by the number of sides, because that's also the number of angles on the inside of the shape. So that'll tell us what one individual angle is worth. Well, we've been told what it's worth. Each interior angle is worth 162 degrees. Okay, so we can kind of start working our way through here. Now, one thing that we can do is we need to get ourselves to here, which means that we need to solve for the t and put it into this equation so that at the end we can figure out what n is. Well, if we're going to do that, let's take a look at this second equation. If I wanted to know what t is equal to, I'd have to get t by itself. So on this second equation, I'm going to rewrite it as t equals the sum divided by 180. Okay, that will allow me to put this thing into here. Now, what is the sum? We're going to kind of have the same problem here. We don't know what the sum is, so we need to get the sum by itself. So we need to rewrite this equation. Well, if I multiply both sides by n, then I get the sum by itself. The sum is n times 162. Okay, so now what I should be able to do is I should be able to do a bunch of substitution here. I should be able to say, okay, that second equation, I can say that t is equal to, well, now I know what the sum is. It's n times 162 over 180. And in my first equation, I can replace this t now because I know that t equals all of this stuff. So I can now make the equation n minus 2 equals all of that stuff. N times 162 over 180. Okay, now I'm just trying to solve for n. So let's take this one and move it somewhere else where I have a little more room to write. Oops. Not working out. Sorry, I guess I'll just rewrite it. It's not working very well. N minus 2 equals n times 162 over 180. Okay, so if we're trying to solve for n, it needs to only be on one side. So for example, I can't just add 2 and say that n equals n times 162 over 180 plus 2. I mean, you can do that step, but you never want something solved where the thing you're solving for is it in its own answer, because then that kind of makes like this endless rabbit hole kind of thing where if all of this is what n equals, then I would be able to put in all of this in that position, but then I would still have all of that stuff and I'd be able to replace it again, and you just have like an endless equation that would never end. It would just keep going deeper and deeper. It wouldn't really do what we want. So we want n to be by itself, some number over here, no letters on the right side. So how can we do that? Well, let's go back a step. Let's do something different. So in order to get at this n that is on the right side of my equation, I need to get rid of the bottom part of that fraction first. So what I'm going to do as my first step is I'm going to multiply 180 on both sides so that I'm no longer dealing with any fractions. Then at that stage, I'm going to distribute that 180. So I'm going to have 180n minus 360 equals, and then I'm going to rewrite that as 162n. Okay, now at this stage, we're looking a lot better. We've got our quantities of n by themselves without having anything done to them. I can subtract 162n from both sides now so that it's not on both sides. And if I do that, if I take away 162 of these, I will have 18 n's left and 0 on the right side. Now, if I just want those 18 n's by themselves, I just need to add 360 to both sides. Okay, at this stage, we don't want 18 n's, we only want one of them, so we're going to divide both sides by 18. I think this puts us in the same situation as another problem where 360 over 18 should equal 20 because 36 over 18 is 2. So it looks like we have a 20-sided shape. Okay, kind of a long process there, but as long as you understand each individual step of these 3 steps, then you have the pieces needed to kind of put everything together. So as a quick review, does a good job of reviewing this whole lesson, this problem. The first thing is that however many sides you have in your shape, like if I have 5 sides, some pentagon or something, then I can divide that into 3 triangles, n minus 2 number of triangles. If I take those triangles and multiply by 180, well, then that will give me what all of the angles on the inside of my shape was, because it'll give me 180 degrees for each of these 3 triangles. It'll tell me the sum of the angles. If I take that sum and divide it by how many angles I have, or if you want to call it how many sides you have, they're going to be the same number, then that will tell you what one individual angle is worth. Okay, so those are kind of the 3 different things that we would write out to figure out how many, to relate like the number of sides to the angle that we expect for one of those angles on the inside. From that point, it's all just substitution to try to get an equation where we have n in the equation with no other letters. So if we're looking at this first equation, with n here, we know we want to replace this t with something else. So we take our second equation and put it in terms where it's t equals something. We get t solved by itself. Then we plug in anything that we need to over here, like this sum. Well, same story. We have another equation where we need the sum written, sum equaling something, so that we can plug this stuff in up here, and then we can plug all that in for t. Once we do that, we get to this final equation that only has one variable in it. One really important thing to just kind of know as a fact about algebra is when you're solving an equation, an algebraic equation, you need to have as many equations as you have letters. So if you have one letter to solve for, you can do that with one equation. But if there are 2 letters in your equation, you can't solve this by itself. N minus 2 equals t, that does not have one answer, right? N minus 2 equals t. If I have 2 letters in one equation, well, then I could have anything. I could have 5 minus 2 equals 3. I could have 6 minus 2 equals 4. This does not have one answer. This generates a line on a graph. It generates like a series of different combinations that work. you're looking for one particular answer, you need to get your equations in a form where you only have one letter in. And then at that stage, it's all just different types of arithmetic to get to your final value. Okay, so that would be lesson one. Well, let's put that in 20 sides. I'll close off the video here. So if you need to go through that to catch up and review at another time, then we will have that video uploaded on Canvas, and I will put it, I'll just put it on the assignment page on Canvas for that assignment. We'll take a quick break, let's say about 5 minutes, and we'll come back at 10:45 for the second set of homework.